All right, everybody. I'm echoey again. Okay, so now we got Friday's work. Unit 7, angles and triangles. So this is the first half of Unit 7. So it deals with your angles, with like transversals and stuff like at the bottom there, and then like vertical angles, and then kind of just like these like angle. Really, they're just like puzzles. And yeah, then it goes into the beginning of Pythagorean theorem. Then you have the other half of Unit 7, which we are going to do Monday. So, write your name on this. Using the diagram, classify each angle by vertical, adjacent, congruent, complementary, and supplementary. You guys are pretty good at that. I think we're going to skip this one. Missing angles. So, straight lines. You need to use the fact that a straight line is 180 degrees. So this angle plus this angle will make that straight line 180 degrees. You have x plus 36 equals 180. And you can go ahead and solve for that. Same goes for this one here, right? We have x and 27. For this one, those two are complementary. They make a 90-degree angle. So use the fact that these two added together will equal 90 degrees to solve for x. Here, vertical angles, 94 on that one right there. X equals 94. That's about it. Then you have some other things where you have to use your algebra skills. Let's see. Let's go ahead and do 5. For this one, we have a right angle. So we know that these two angles added together are complementary. They add up to 90 degrees. So equals 90. We have 2x plus 16 plus 6x minus 14. Now, I'm combining my like terms. I have x's and I got numbers. 6x, 2x, those added together are going to equal 8x. Then on this left side, I have a negative 14 and then positive 16. That's going to be a positive 2. And then equals 90. Now we'll subtract 2 from each side. We get 8x equals 88. Then divide each side by 8, and you get x equals 11. Now, for this one and this one, they're just saying to solve for x. So you don't need to plug that back in to find any of these angle measurements. For this one, these are vertical angles. Do what you want to do with your vertical angles. You know, yeah, I'll tell you. They're congruent. They're the same. So set them equal to each other. Then, let's see. For this one, it's the same thing. It gives you L and K, which is that one right there, and it gives you K and M, which is this one right there. So those two we know are supplementary. Use that fact and set these equal to 180 and solve for x. Then at the end, you need to plug it back into your L and J. So you're gonna have to use the fact that these two are vertical angles, and you can actually just plug it back into K and M, and then that should work. And I'm not gonna do that one because you guys can do this. Let's see. If P and O are supplementary angles, measurement of angle Q is 47. Find P. 90 minus 47. You guys got that. All right. That's enough of that. Let's see what we have over here. For this was on one of your recent, well, not recent, but one of your older quizzes. You need to do 2 things. Well, not 2 things. There's 2 angles in this whole thing. 2 angles. All the ones that I am going to circle are the congruent ones. Now, those are really easy to tell because we have an obtuse angle and an acute angle. If you find one, then you already have 4. So in this list of numbers over here, you should have 2 of the same number repeated a bunch. So you're going to use the fact that m measurement of 5 is 118. Then you could figure out what 3 is. Those are interior angles. Yeah, those are, what do we call those? They're not alternate interior angles because those are congruent, but those are, are they like adjacent? Something like that. You guys got this. 2 angles for the whole thing. There you go. This one, these are alternate exterior angles. What we know about alternate exterior angles is that they are congruent, set them equal to each other. So that should look like 12x plus 8 equals 116. Now we're solving for x here. We got to do 12x. We're going to subtract 8 from each side. Equals 108. Then we're going to divide each side by 12. 108 divided by 12, we get 9. X equals 9. You're done with that one. I just did it for you. These are similar. This one, remember, these, I think we call them adjacent angles. These are going to add up to 180. These are going to add up to 180. So do what you want to do with that. Now, 14 and 15, you have to solve for x, then plug it back into your equation and solve for y. Let's do one of these. So we're looking for the measurement of angle 1, but the first thing we have to do is create an equation with what we know. We have this angle and this angle. These are supplementary angles, so they equal 180. 10x minus 6 plus the second one, 7x plus 33 equals 180. Now, we're going to combine our like terms. We get 17x. We have a 10x and a 7x. Those added together gives you 17. 33 and a negative 6. We have 27. So plus 27. Then that left side is good. We'll rewrite our 180 on the right side. Then we'll subtract 27 minus 27. And we get 17x equal to, what is that, 153? 153 divided by 17 is also 9. So if we divide each side by 17, x equals 9. Now, we need to find the measurement of angle 1. Well, we don't have an equation for angle 1, but what we can do is we can take its vertical angle because we know they're congruent. We do have an equation for this one. So if we plug 9 in for our x here, we know that's the same angle as angle 1. So let's do it. We're going to use our 9 and plug it in. 10 times 9 minus 6. That is equal to 10 times 9 is 90 minus 6, 84 degrees. You're done with that one. You're going to have to do the same thing on this one, except those do not equal. Oh, no, they do equal 180. You can do the same thing there. Missing angles in triangles. Not too bad. What you're going to do is you're going to use the fact that all of these sum up to 180. So each angle, 60 plus x is equal to 180. So you're going to go 180 minus 60 minus 60, and you'll get x. Yeah, so you're just using that fact that our angle measurements in a triangle all add up to 180. On the bottom here, we have another one, except we're solving for x. First thing we need to do, add these all up and set them equal to 180. 14x minus 1 plus 62 plus 77 equals 180. Now, we have 14x minus 1, and then a bunch of numbers. So this is our only term with a variable in it. So we can leave that alone and just combine everything else. We have, I'm going to do this on the calculator, 62 minus 1 plus 77. We get 138. So 14x plus 138 equals 180. Then what we're going to do is we're going to subtract 180 from each side, or 138 from each side. 138. 38. 180 minus 138 is 42. We're going to set that equal to our 14x, right? These are canceled out now. 42 divided by 14, I think it's 12. It's not, it's 3. We have x equals 3. And we're done because they only asked us to solve for x. And this next one, you have to plug it back into your angle. All right, last side, Pythagorean theorem. I am just going to give you the formulas and then I'll set you on your way after. Now, I believe on our test, we do have a problem that is like one of these where it's a word problem that you have to set up. So, a squared plus b squared equals c squared, where A and B are the legs, and C is the longest side. C is the hypotenuse. All right. We are gonna, I'll let you do these. You can do these. A and B are your legs. Your hypotenuse is your X in this one. Your legs are the ones that make up the 90-degree angle. Those two added together, squared, equal your C value. Let's just do one. Let's do one real quick. Let's do 23. We have X is one of our legs. Let's call it A. Our B, we're going to call 7 squared. Then our C is 23. So the first thing you always have to do is you have to square your numbers first. Then you can combine them. 7 squared is 49. X plus 49 equals 23 squared, which is 529. Should be a squared on that X. Then you can subtract 49 from each side. And you get 480 equals X squared. All right, now what we got to do is we got to square root our 480. The way we do that, second square root button, 480, close that parentheses, then click enter. 480 is not a perfect square, so it's going to be an irrational number, 21.9. So we'll round it to our nearest tenth. And that's about it. When you're determining if the sides of a triangle are right, you're using the inverse. Maybe it's the converse. I don't know. You're using the opposite of what you've been doing. You're using the Pythagorean theorem to see if the left-hand side equals that right-hand side. So you're going to go 7 squared plus 10 squared equals 15 squared. Make sure your longest side is that C value isolated on one side of the equation. Then what you're going to do is you're going to multiply all these out, add this left side together, see if that left-hand side gives you the same number as your right-hand side. If it does, then it's a right triangle. If it doesn't, then it's not a right triangle. Peace.